You might have noticed how much time I spent on those power laws, because it's so fun mathematics. It's so beautiful. And a lot of the stock market people who brought us the financial crisis, they used similar methods, and they were also seduced by these beautiful models, which turn out to have some flaws. Some flaws which were pretty well known, but kind of unknown knowns. Everybody knew about it, but didn't want to notice that. So we should avoid having too elaborate models for many of these problems. Similarly, we should also acknowledge embarrassing problems with our lack of knowledge. One of the big problems with risk society is that a lot of politicians claim to understand uncertainty much better than we do. A typical example is the climate debate, which is completely horrible. And there is a lot of good reasons to believe that climate change is real and that we should do something towards it. But then that gets motivated by a lot of very rickety statistical and economical and climatological models, which we really shouldn't be trusting too far. The downside is, of course, that admitting that, okay, these models point in a rough direction, but not giving us exact data, that doesn't really sound as good as saying, oh, we know exactly how many thousands of kids are going to get killed in 2070 if we don't immediately implement this tax. Which is pretty ridiculous if you were to say, oh, I know exactly how much the stock market will respond in 2070 to this tax. Everybody would immediately recognize that you're actually not having any data. But I think we need this if we want to do real risk estimation. We also need to think about robust ways of acting. So this is especially important for big disasters. So Nick suggested in his existential risk paper something called MaxiPOC. Maximize the probability of being okay. One way of formulating this is that in a game you might not just want to maximize your returns. You might also want to maximize the length you're in the game. So if the game is life, you don't want to gain a lot and then just die from it. You actually want to make sure that you can continue playing the game. In the case of wars, well, make sure that we can give some concessions now if it actually increases the likelihood of not getting a war. So for example, the European Union, by getting everybody involved in everybody's pocket, is probably great for keeping Europe safe and peaceful. Then there is, of course, the interesting things we as transhumanists can think of. We're quite interested in the future. And we're quite willing to think about the risks that most other people think are completely silly and ridiculous. Which I think is a good thing that we are thinking about. Because if nobody is studying a risk, we're not going to get protection. If one person starts studying this silly risk, the amount of research about that risk has actually increased an infinite amount. So even small groups can actually do quite a lot of useful things. Asteroid hazard, for example, has been for a long time been a very fringe activity in the space program. But as Nature put it, the burger bar that saved the world, and they would have formed, I think, around about 7 people who essentially drove most of the research that have reduced the risks quite significantly. So by having, let's say, the typical example might be friendly artificial intelligence, which is a subject that right now is not of interest to very many people. But I think the few people they're actually doing great stuff just because we exist. We might get much more done if there are 1,000 people thinking about how to make safe or super intelligent artificial intelligence. But that's going to be tricky to get funding for. But on the other hand, just getting these few people to work on. So you can do a lot of interesting preparation. I found a wonderful supernova survival guide, for example. One guy who'd been thinking about survivalism against the threat of nearby supernovas. Of course, the big problem is that they're not very likely to be, but he's also argued that this is going to work against gamma ray bursters too. And in good old American survivalist style, he actually figured out something that I think makes a lot of sense. So you could probably set up his scheme. And it's probably a good thing that there is a few reports and analysis of how to engineer a good gamma ray burst shelter. Another interest, there is a very important psychological angle to this. Not all risks are bad. There are a lot of risks that are actually quite worth taking. And one shouldn't let the concern about the bad risks allow us to miss that there are a lot of good risks we should aim for. I don't think there is any security at all on Earth. There is only opportunity. Well, thank you.
Questions?
No, that was a very robust question.
And is your name actually quite common
in
Sweden?
Oh yes, 4 people at my old research group were named Anders. We had to use our email addresses.
No, I meant what your surname, Sandberg.
That's also relatively common.
Yeah, relatively. Yeah. It's just one of the things you were saying about lost records, apart from losing records. I mean, my name's David Turner. It's about the most common name in the country next to John Smith. So the problem I've had with databases continuously is not they lose records, but they get me confused with someone else, basically.
Which is probably a much bigger problem than losing records, because that confusion can be much more dangerous.
It's insidious, basically, because that gets copied to another database. We spend
yeah. So one risk we don't have a good way of quantifying is, of course, data corruption. And it's an awful lot of it going on. Sometimes it's pure alpha particles hitting a memory cell and flipping a bit. And sometimes it's a fly flying into the printer, but most of the time it's somebody mistyping or misunderstanding or misaligning 2 tables in Excel. And suddenly we get all sorts of amazing data which just percolates.
Yeah. Anders, rather than, I mean, when you're predicting probabilities, rather than calculating them from evidence, where exactly do you draw the line in terms of principle of parsimony? As in, I mean, I suppose this depends on your philosophy of history or whatever determines your philosophy of history, but I'm just wondering where you think the line should be drawn.
That's a good question, and it depends very much on what kind of data set you got. For example, a lot of those plots I had was based on a particular data set which is curated by some disaster organization. So a lot of people who care a lot about disasters are handling that data, so I kind of trust them. But there is already a cut-off situation because, for example, old pandemics, we don't have much good data from before 1940 about the size of pandemic. So that data should be suspect. So quite often I run various tests to try to see, are there biases in the data? So for some of the calculations, for example, it turns out that one should only use disaster data from after 1970, because at that point we had the modern kind of monitoring network. But on a more deep level, of course, the principle of parsimony is also about how you set up the model. The nice thing about power laws or extreme value distributions is that it's actually a very parsimonious approach. You don't have that many free parameters. But there is still enough wiggle room to get a little bit of uncertainty, and that makes me a bit nervous. I'm not really looking for an exact probability of anything. I'm more interested in the relative ranking of probability. Should we really be trying to fix democide more than flu epidemics, for example? That might be an important policy decision. But I think in general, of course, the principle of parsimony also goes towards thinking about both your preparations and estimations of risk. How complex are your models? Are they simple and robust like that the multiple branched one, or do we depend on some very elaborate physical mathematical model? In that case, I think it's likely that we're going to be in trouble. So, yeah, in general, parsimony always tend to win out in the long run.
So let's explore that a bit more. I mean, you're saying you're trying to figure out which risks deserve the most investigation. So if the EU or the British government or a very rich donor comes to you in your institute in Oxford and says which of the risks are most worth research and some action, which based on all that you've seen, based on the input at the end of the Global Risk Conference a while back, what do you pick as the top 1 or 2? Because most attention.
There is a combination here that some risks are probably easier to move than others, but they might have a small probability of hurting us. So I think the 2 areas I would go for would probably be things that work against several risks. So a general kind of pandemic preparedness, if you could expand that also to handle bioweapons, that would be very useful. Also, we need to construct more resilient societies that can handle internet crashes, power outages, or that suddenly the capital just goes missing for no obvious reason whatsoever. Whether that is due to a painting, a nuke, or a meteor strike, doesn't really matter. What do we do if the capital just disappears? So I would probably tell the donor that if he wants a neat project, we should go for biosecurity. Some kind of monitoring system to figure out the misuse of biotechnology and check emerging pathogens. A bigger research project would probably be useful, but would be hard to push, would be building resilient societies. That's something I think James Martin